Alright, and welcome to the third part in the Linux Fundamentals series for the CySec 101 pathway. And this is going to be our last fundamentals video for Linux. There's other videos that are going to be coming up for Linux Plus certification, so on and so forth. And in this one, we're just going to be going through some text editors and general useful utilities, processes 101, maintaining system automation, maintaining the package management, and of course system logs. So it's going to be a fun one. It's going to go over the rest of the fundamental concepts so that you understand how Linux works. And from there, you should be primed and ready to go to jump into the Linux Plus certification video that will be launched in a week or two. So I'm excited about this one, and let's jump into it. Okay, so we learned about Secure Shell in the very last video, so the Linux Fundamentals Part 2, Linux Basics Part 2 is probably how it's going to be named. And we learned how we are supposed to use the attack box that we got to secure shell into it. Now, if you want to use your own computer to secure shell into it, you're more than welcome to. You got to connect to the OpenVPN server or the configuration file that is available through TryHackMe to be able to connect to all of their virtual machines in this regard. But if you're using the attack box and just the TryHackMe service by itself, once you click the start machine, you get the IP address that populates at the very, very top right here. And the command is very simple, right? So you do SSH, TryHackMe, add that specific IP address, and then this is the password. So the username is TryHackMe. So let me just show you. It's probably easier to do it this way. So we're just going to run SSH TryHackMe at the IP address, which is that. You press enter, it asks you, hey, do you want to do this? It's going to create a SHA-256 hash for the fingerprint, and I say, yes, I do want to do this. And then now I'm going to provide the password, which is TryHackMe. Takes a couple of seconds, and then we are inside of the Linux machine that we're supposed to be connected to. So I'm going to run clear to clear up the terminal, and that's basically it. You're logged in. We're logged in as TryHackMe Linux 3 because it is part 3 of the Linux Fundamentals video. So now that we're in here, let's actually go into the terminal text editors here. All right, in the last couple of videos, we actually went over how to use the echo command to pipe information, or essentially input or send information into a text file by using a single greater than sign or the double greater than sign. And this is an efficient way to handle data when you're working with a lot of files, and if you want to just dump a bunch of data inside of a file. So you could technically take the output of any command and dump it inside of a file using these specific operators. So once that data is inside of a file, you need a terminal text editor. And my favorite is Nano, but Vim is also very, very popular, and a lot of people use it. And there's actually rooms that are dedicated to these things. So we're not going to go into the depth of what these things are and how they work and the various options that come with them, but you should be able to actually work with them and navigate what they do. So in this case, inside of the temp directory, there was a my file, and they did nano my file, and it opens it up, and this is what it looks like, right? These are the contents of my file, which is basically, that's it, right? All these options that you see right here show up at the bottom of any individual nano computer, or text editor. So if I am inside of the Linux machine, I do print working directory, and I do an ls, and I see that there is a task 3. And if I do try to go into it, it's actually not a directory. So I know I can do nano task 3, and it'll open up what's inside of task 3. And it says THM text editor. That looks like a flag, and we're probably going to use it later on in this particular task that we're in, right? So THM text editor, and then we have all the options at the bottom right here. These are the options that I was just talking about. And these individual options could be, where is right here. I use this a lot because I'm trying to search for a specific string or email address or a pattern, anything like that. You use where is. It's basically find. You can find something inside of the individual file that you're in. When you do Control O, and that's what that upward arrow is Control. even on Linux machines or even on Mac OS machines, it's control, it's not command, right? So control O would write it out, and then it'd say, are you sure you want to write it out? And I say, yes, I want to write it out. So let's actually do it, right? I'll just do modification, right? That would be my new text. And then I have to do control O, and it says file name to write. You have to press enter to actually write it, and you say, okay, cool, you wrote 2 lines. And I do control X to exit, and now I've exited. So if I run the cat task3 command, now I have the modification that I added using the text editor, right? And that way you can add a bunch of lines of text or even write scripts inside of a file by using Nano, right? So that's what Nano essentially does, and it's a very, very useful text editor. And if I don't have a file already, instead of using Touch to create the file, what I can do is I can use Nano to create the file, and it'll open the file as soon as I've created it. So I can do Nano my file and then just open a file for me, and then now I can write whatever I need to inside of the file, and then go ahead, and if I want to exit out, so instead of doing control O to write and then pressing enter, if I just did control X to exit it, at the bottom it says, hey, do you want to save this? And I can say, yes, I want to save it. And then that's it. Now I can exit out, and I can do cat my file, and it'll show me all the jargon that I just typed into it, right? So Nano can actually even create a file for you. And then we can go and this is what we've done right here. So we already did all of that. So write and create. So we're actually way ahead of the game here. The next one is Vim. It's a much more advanced text editor. You're not expected to know all the advanced features. It's helpful to mention how you can power it up and how you can exit, right? So we can go here and we can do the various pieces. I mean, there's actually no other commands that they've given us to run. They just told us how to power it up and how to exit out of it. But some of the benefits here include that it's customizable. You can modify keyboard shortcuts. There's highlighting of the syntax. So if you're writing or maintaining code, you can actually see various color coding and highlighters. That makes it just easier. It works on all terminals where Nano may not actually be installed. And there are a lot of resources such as cheat sheets, tutorials, and everything that's available for Vim. And same thing is available for Nano as well. So it's not to imply that all these things don't exist for Nano. As far as cheat sheets and tutorials and things are concerned, there's a room that showcases Vim that I actually have not gone through. So I will probably do that at a later point. Let me just open it on a different tab so I don't forget it. So, okay, so let's just open up Vim real quick and see what we can do here. All right, so we have a new file. So let's say we're going to do vim file.txt in this particular case. And now, there we go. We got an empty file using Vim, right? And I can go ahead and essentially just do, what is this? Colon. So not semicolon, colon, and Q is how you would exit out of this. So it's at the very, very bottom right here that you can see. So colon, Q, and then you press enter, and it exits out of it, right? So that is essentially how you interact with Vim, and you can essentially just do Vim, the file name, and it'll open it up. And in this particular case, it didn't create a file for us because it was just an empty file and we didn't do anything to save anything from it. So that was essentially just kind of just how to open it and how to close it. If I just did Vim by itself, it'll give you a few helpful commands at the very beginning. So for example, type colon Q to enter or to exit, excuse me. So colon Q and then press enter and it'll exit. If you do colon help, enter, or F1 if you have a keyboard that has that, it'll give you a one-line help menu. And if you do colon help and just press enter, or excuse me, colon help space version 8, press enter, it'll give you the version info. And then of course there's the actual help menu itself. If you do colon help sponsor, it'll give you the information itself. If you just do colon help enter, it'll give you the help menu. So It's very, very basic. We're not going to be going through anything fancy with this particular tool. You just need to know that it exists, and there are two text editors. My default is Nano. I just go through Nano because it's more, I don't know, I think I've just used it so frequently that I'm more comfortable using Nano. But you have access to both of them. You have Nano and Vim that's available. So right here, it just says create a file using Nano, and we've done twice actually. And then edit task 3 located in TryHackMe using Nano. What's the flag? And we already got that one as well. So we were a little bit ahead of the game for that particular question. So let us talk about these other utilities here. If you want to download files, you can use the wget command. And it's a fundamental feature of computing, especially in Linux, right? So if you want to transfer files or download files, you can use the wget command. What you need to do is give the full URL of where that file is sitting, including the file name at the very, very end of it. So if you do wget https yada 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 yada, and then make sure you have the full thing, it'll download myfile.txt into whatever directory you're actually in. So I'm just going to run this because I do want to see if there's actually a file over there. So I'm just going to copy this particular command. I'm going to go here and I'm going to paste that command, and I'm going to press enter, and it says connecting to etc etc. And let's see if it's actually going to complete the download. Okay, I waited for literally like 5 minutes at the very least, and I even tried to remove the my file that was already inside of our directory just in case it was having a problem rewriting over it, and it still did not download. So that particular asset is not being downloaded, unfortunately. However, maybe it doesn't even exist. Maybe this is just something that they put over here just to demonstrate the command, but I have used wget before to download things previously, so I know that it does work. It's just in this particular case, it didn't download this particular file for us. You can also transfer files. So in this particular case, we're transferring from our host into another location, and it is very similar to running SSH. It's called SCP, which stands for Secure Copy. And it's literally securely copying files or transferring files from one location to another. So this command allows you to transfer files between two computers using the SSH protocol, meaning on port 22, to provide both authentication and encryption. Working on a model of source and destination, it allows you to copy files and directories from your current system to a remote system, copy files and directories from a remote system to your current system. You can do both of those things. Provided that you know the username and the password for a user on the current system and on the remote system. For example, if you want to copy an example file from the machine to a remote machine, which they have neatly laid out in the table below. So the IP address of the remote system would be this. The user on the remote system is Ubuntu. The name of the file is important.txt. And then the name of the file that would be transferred, because you do have to provide that as well, is transferred.txt. So this is what the full command will look like. You have SCP, the original file, important.txt, being transferred to this person, right? So Ubuntu at this IP address, colon, and then the path that you want it to be transferred into. So this part is very, very important, right? You need to actually provide the path as well as the file name that you need to that you want it to be transferred into. So if you wanted to reverse this process, so this is us transferring the document from where we are to this other person, and once you press enter on this command, you're going to be prompted for Ubuntu's password on this IP address. So just keep that in mind. We're not seeing that, but you're going to be prompted for that person's password to be able to actually transfer files into their computer, right? So if we want to reverse this and get the syntax for using SCP to copy a file from this place into our local machine, this is what we would do, right? So the name of the file on the remote system and what we want to have it look like on our system. So we're going to do SCP, and instead of putting this first, we're going to put this first. So you do SCP, Ubuntu, etc., etc., the location of that file, which again also is a big requirement is that you need to know exactly where that file is sitting on their computer to be able to transfer it. If you don't know, then it's not gonna search for the file for you and try to find it conveniently. You need to know exactly where that file is sitting, and then you press notes.txt, which is the location on your current directory, wherever you're logged in, and whatever your current whatever your working directory is, that's where this is going to be saved to. And that's it. Once you press enter, again, it's going to ask you what's the password for this particular user. Once you enter the proper password, then it's going to transfer the file for you. You can serve files from your host, meaning you can turn your computer into a server so somebody can go and download the file from wherever it's located using wget or curl, right? It's actually something that we've used a lot to transfer shells, shell scripts that we created on our computer, or Metasploit payloads that we created using MSF Venom on our computer. We transfer it to the target machine using the Pt.3 server. And this is actually very, very easy to do, very simple to do. You just do Pt.3-m HTTP server. If you don't designate a port number, it'll just choose the basic default port number and it'll tell you what it is. So let's actually do it here so you can see what it looks like. So I'm actually currently logged into the TryHackMe Linux computer. So I'm going to open up a new shell that's going to show me logged in as my specific user, which is root, right? So if I do Pt.3-m HTTP server, press enter, and it says it's serving on port 8000, which means the IP address that we have, :8000, which is what? It's this IP address, 10.10.112.100. So if somebody wanted to download this, if I wanted to download the file that's on this current directory from this directory, if I wanted to use it using this server to download a file that's on this machine to this machine, I would need to go to 10.10.112.100:8000. That's where that's what the URL would be, and then / the name of the file, assuming that it's just sitting in the current directory that it's in. So now I just do Control-C and I close out that server that I've created, and it's gone. So what you can do, again, this is what it looks like, right? So you've created the port 8000 server on your specific machine that you have, and then so you would use wget, the IP address, followed by the port, and then my file, and now it will download it onto the machine that you're on, right? Pretty interesting stuff, like easy. It's fairly easy when you think about it. So I'm going to try to see. So what do I have? I have the task3 file is the only thing that I have here, and it's sitting on the home TryHackMe directory. So I'm going to try to do Pt.3-m HTTP server. Let me see if this actually has it. It does have it. So now I can download this file, the task3 file, from this particular location on my machine. So I need the IP address of that target machine, which is this IP address right here. And I already know that the username and password is TryHackMe. So I can go ahead and do wget, and I will do HTTP, and I will paste the IP address, and I will do port 8000 and / this is the important part right here, home TryHackMe task3. So I'm just going to do home TryHackMe / task3, enter. And it says file not found. So let me see, home TryHackMe task3. I feel like that's exactly where it would be, right? So on port 8000 of this particular location. So let's see, maybe I did, because the connection was right, the request was fine, but the file itself was not found. And this is actually saying that somebody's trying to access this particular file, but we gave a 404 error, so file was not found. So I'm just going to run the command one more time, and instead of doing home TryHackMe, etc., let's make sure that we're actually running the correct command as well in this particular case. So they did this, my file, yeah, so that's fine. So in this particular case, what I'm just going to do is I'm going to delete all of this preceding stuff, and I'm just going to do task3. There we go, and it actually worked. So because I served this particular piece from this directory. I didn't need to do this as a prefix. I just needed to just type task3, and it actually worked. And now if I run ls on this machine, I can see that I have that task3 file, and I can even concatenate it onto the screen and have the contents of it printed. So that's very, 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 very useful. Believe it or not, you're going to use this a lot. So Python 3 -m HTTP server, and very, very useful information, and you'll probably use this a lot. So this is what it looked like when we were able to actually download the file, and this is what some of the screenshots look like when you run and download it. So that is it. So to start a web server in the home directory of the TryHackMe user, download the file flag.txt on the attack box. Remember, you'll need to do this in a new terminal and get that flag. So apparently there's actually a flag that is on that computer. So I'm going to just do this because I already have that connection, and I'm just going to do .flag, right? That's what it is, .flag.txt, and download that. There we go. And now we should have a, whoops, I should have a flag dot, where is it? It should be a secret file. Where's my secret file? There we go. So .flag.txt. So now I need to concatenate that onto my screen, and it's very important to put that initial dot at the beginning of it as well, because it is a hidden file. Press enter, and now we have thm wget web server, which is the flag that we got right here. So very, very cool. So now we have Control C to stop the server, and we'll just do that, and we have exited our server. And now we can move on to Processes 101. Processes are the program that are running on your machine. They're managed by the kernel. They are running behind the scenes. More often than not, you will not really see them because they're just running, right? They're managed by the kernel. They have an ID associated. It's referred to as the PID. And the PID increments for the order in which the process starts. So for example, the 60th process will have a PID of 60 because it started at the 60th position, right? It was the 60th process to start. Viewing processes can be as simple as running the PS command. So you provide a list of running processes as the user session and some additional information like the status code of it, the session that it's running in, and how much time or how much usage time of the CPU it's actually using. The name of the actual program or command that's also being executed is also there. So for example, PS in this case will show us a PID of 204 for the PS process that's running, right? 205 in this particular case will show us again because they ran it again. So now it's been incremented by 1, right? And it gives you the name of it as well as the PID itself, how much time it's using, and in this case it's not because it's not a big process that's running. So in the screenshot above, the second process has a PID of 204, and then in the command below it, it has incremented to 205. If we want to see processes run by other users that don't run from a session, we need to provide the aux to the PS command like this, PS aux in this case, and it'll show all the other users that are also running processes and what their processes are, what the start time is, how much of it is actually using, so on and so forth, and the command that are running in this particular case, which we can see as well. So we see a total of 5 processes now, and we have root and cmnatic, which are the users. So another helpful command is the top command. So it gives you real-time statistics about the processes that are running on the system instead of just a one-time view. So it actually updates in real time. And these statistics will refresh every 10 seconds, but will also refresh when you use the arrow keys to browse the various rows. Another great command to gain insight is the top command. So this is what it looks like. You run top, you just press top and you press enter, and it shows you what all the users are, and this will change every 10 seconds based on the CPU usage and a variety of other items or variables that are associated with each of these processes that are running. And it's also something that's very important to check just to see what's going on with the CPU usage of the computer in real time, to see if there's any specific process that's taking up more information than it should or more data than it should, or if there's a process that just jumped on that shouldn't have, and a lot of other things that it's beyond the scope of this particular video, but it shows you a lot of great detailed information about the processes. So let's say you have a process that you want to terminate. So you can use the word kill, right? This is probably one of my favorite commands just because of the name. There are a variety of types of signals that correlate to exactly how cleanly that process is running and it's being dealt by the kernel. To kill a command, we can just say kill 1337, and 1337 is the PID that's associated with it. So you just say kill, and then you provide the PID, and it'll just kill it. It'll just stop it from running. The signals that we can send to process when it is killed is sigterm, so kill the process but allow it to do some cleanup tasks beforehand. Sigkill, kill the process, no cleanup after the fact. And sigstop, to stop or suspend a process. So you can say kill sigstop, or just say kill 1337. And kill 1337, it just shuts it down immediately, right? How do processes start? This is a very complex topic, so we're going to do an overview here. So first we need to understand what a namespace is. The operating system uses namespaces to ultimately split up the resources available on the computer. So for example, the CPU, the RAM, and the priority of that process. And you can think of it as splitting the computer into slices, like a cake. So processes within that slice will have access to a certain amount of computing power. It'll be a small portion of what the overall computer can do, right? So if you have 10 gigabytes of RAM, you've taken a 1 gigabyte slice, and that process or those series of processes have a maximum of 1 gigabyte to use, right? Namespaces are great for security because it's a way to isolate something, and only those processes that are in the same namespace will be able to see each other. And if there's something wrong with them, they stay within that namespace. It's just an easier way to manage them if anything happens. So we previously talked about what PIDs are and how they work, and this is where it actually comes into play. So the process with an ID of 0 is a process that started when the system booted. So the very first thing. This is the system's init, right? The initiation on Ubuntu, such as systemd, which is one of the system initiation processes, is the most recent one. There's sysvinit, sysvinit, which is kind of the older initiation software initiator, and these things provide a way of managing the user's processes, and they sit between the OS and the user, right? So once a system boots and it initializes, systemd is the first process that is started. Any program or piece of software that we want to start will known as a child process of systemd. So systemd will be the parent process, and it will have a PID, which is the parent process ID, and everything under systemd will be its children, its child process. They'll have their own PIDs, but they can also be parent of other processes, of sub-processes. So what it means is that everything is controlled by systemd because it is the very first one. But it's going to run as its own process, also sharing resources from systemd to make it easier for us to identify, and so on and so forth. So the very first one right here, see that's a PID of 1, not PID of 0, is systemd. It's the very, very first one, and it's the user that belongs to it, obviously, is the root user. So if you want something to start on boot, meaning as soon as the computer is started, as soon as the machine is started, we need to actually schedule it or configure that process to run on boot. So for example, some applications can be started on the system that we own, web servers, data servers, or file transfer servers. The software is often critical and is often told to start during the boot up of the system by administrators. In this example, we're going to be telling the Apache web server to be starting Apache manually and then telling the system to launch Apache 2 on boot. So we enter systemctl, which I believe stands for system control. This allows us to interact with the systemd process daemon. So what it does is that it's an easy to use command that takes the following formatting: systemctl, the option that you want to do, for example, start, and then the service name. So you say systemctl start Apache 2, right? Same thing, systemctl stop Apache 2, systemctl enable Apache 2. Enable usually comes before start, right? So you can't say start if it hasn't been enabled. So you would say systemctl enable Apache 2, and then start Apache 2. Then you would stop Apache 2 and then disable Apache 2, right? So that's the order of these things. It's kind of not in the proper order here, but that's, if you kind of think about it logically or commonsensically, you can come to that conclusion yourself. So it seems simple, right? So if we wanted to stop Apache, so on and so forth, same thing. These are the commands that we run. And then there's backgrounding. So these are, again, just very, 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 very high altitude overviews of these concepts. We're not going into the depths of these concepts here. I just need you to understand this is how Linux works. So you just have the basic understanding of the Linux operating system, so that when we go into more advanced videos, you can understand how all of that works. So backgrounding and foregrounding processes is also very useful, right? Especially if you are only dealing with the command line and you don't have a graphic user interface like what you see here. You only have the command lines, which is what you can see inside of these terminals. So a process can run in two states, in the background and in the foreground. For example, commands that you run in your terminal, such as echo or anything of that sort, are running in the foreground of the terminal because it's just providing you the information right onto the screen, and you haven't told it to run in the background. That's the other piece. So echo is a great example because the output of echo will return to you in the foreground, but it wouldn't be in the background because it's literally on the screen, so it's in the foreground. If you did the ampersand, which is what we talked about in the last video of backgrounding a process, if you did echo hi thm and then you did the ampersand at the end of it, you get this notification, and then this piece right here is the TID, right? Or excuse me, the PID, right? So this is the example, the description here. We're doing hi thm excuse me we're doing echo hi thm, where we expect the output to be returned to us like it is at the start. But after adding the ampersand operator, we're instead just giving the ID of the echo process rather than the actual output, as it's running in the background. So this is a great command for copying files because it means that we can run the command in the background and continue on with whatever we need to also execute. And once it's done, you can refer back to it or bring it into the foreground. So we can do the exact same when executing things like scripts. So other than relying on the operator, we can use Control-Z on the keyboard to background the process. It's also an effective way of pausing the execution of a script to see what else you can do, right? So this is going to keep going until I stop it. This is basically the loop that they have. And it's probably, while true, print this onto the screen. That's basically what the script is doing. Until you do Control-Z in this case. And then it's just now in the background, right? And then you can either continue on with it or bring it into the foreground, or you could just kill it. So this script is going to keep repeating until I stop or suspend the process by doing Control-Z, as indicated by this piece right there. Now the terminal is no longer filled up with the messages until we foreground it, which we will discuss below. So all of this is backgrounding, as you've already seen. So this is something that ampersand would be something that you add to the end of a command on the actual command line. The Control-Z is something that you would add to a script that's running. So you run the script, it's doing whatever it's doing, it's taking up space inside of your terminal, and then you do Control-Z and it becomes a backgrounded script. So for example, in this case, we had the Python server, and the Python server was taking up space on our terminal here. So instead of doing Control-C, which is what I did right here, I could do Control-Z. So Control-C killed it, right? It killed the server. I could have just done Control-Z, and then it would have backgrounded the server, but it would have still been running, right? It would have still been working, and then anybody could have accessed that server to get information if they needed to. So foregrounding the process is where we go back to our process list. So now we have the process running in the background, for example, the background.sh, right? Which we can be confirmed by running the ps-aux command, and then backpedal using it back to the foreground. So right here is where you see the list. So let me see, maybe I can. So you can see it. So root has this 19802 PID that's associated with it, and it belongs to the background.sh, right? So while the process is in the background, with the process using in the background with Control-Z or the ampersand operator, you can foreground it. You can do FG to bring it back to focus. So you also need the PID for this, however, right? So we can just do FG, and then where we output this script now into the foreground, and then you can see that it's running as well. So if we were to launch a process with the previous ID was 300, what would be the ID of the new process? Because it increments by 1 with each time that it runs, so it would be 301. If we wanted to cleanly kill a process, what would we do? We would do sig term for sig terminate, and you would combine that with the PID. Locate the process that's running on the deployed instance. In this particular case, what flag is given? So let's actually see if we can go ahead and find that. So the process that's running on the deployed instance, which is 190.79, which is our, it's our target machine right here. So we want to find this particular flag right here. So let's go and try to find this particular process. So let me run ps here. And I did ps aux. And it's right here. Actually, you can see it right there. THM processes. And if we just kind of expand on this a little bit, let me make sure I kind of bring this out into the open. And that's what it is. THM processes is the process that's running. And then we have all these other processes that are also running. So I just ran ps aux because I wanted to see the full list of processes that are running. However, if I did ps, I wonder if that would also show. And it does. It does also show. So actually, no, it doesn't. I'm sorry. It doesn't, because this is the list that only shows for the specific series of processes that are associated with TryHackMe user, not the full list of processes that belongs to the root user, for example, which is where this thing belongs to as well. It's a root user process. So we did ps aux, ps space aux, and we were able to find THM processes. So what command would we use to stop the service, my service? We would be systemctl stop my service. Very simple. What command would you use to start the same service from at the boot up systemctl enable my service, right? And what command would you use to bring a previously backgrounded process back to the foreground? And that would be FG for foreground. BG goes into the background. Control Z if it's a running script, and then you can just do ampersand at the very end of your command if you're executing the command in the terminal, and it would send it into the background, and then foreground would be FG, and it brings it into the foreground. Automation is one of the most important concepts in system administration, mostly because of the fact that there's going to be a lot of repetitive things that you're going to need to do. And if you don't know how to automate, it's going to take up all of your time and energy. So there's a reason why scripting exists. So let's actually make sure that we don't run out of time here with our virtual machine, which is our attack box. All right. In the case of automation, there are a few things that you should just be very, very aware of. There is something called the cron process, but specifically the cron tabs, which is the list of scheduled processes that start during boot, and it's responsible for facilitating and managing cron jobs. So cron jobs, chronological, I believe is what that stands for. So if you look at the tmp cron tab directory and look at the cron tab file, this is what it looks like right here. So edit this file to introduce tasks to be run by cron. To define the time that you can provide for these things, you can look at the minute, hour, day of the month, month itself, day of the week, so on and so forth, or use the asterisk in these fields for any to just make it run at all times. And the task will be started based on the cron system's daemon notion of time and time zones, so you need to also be aware of that. A cron tab is simply a special file with formatting that is recognized by the cron process to execute each line step by step. They require 6 specific values: the minute, hour, date of month, month itself, date of week, and then the command itself that you want to be executing. When you look at it, this is what it looks like on a line item in this particular case, right? So backing up files, for example, is what we're going to be looking at. So we want to back up CMNATIX documents every 12 hours. So we would do the following formatting. So an interesting feature is that they also support wildcard characters, which is what these pieces right here represent, right? So you want to do it every 12 hours, which is what the first part would just be any day, and then 12 hours, right? So if we don't wish to provide a value for that, we can just use the asterisk, which represents everything else right here: day of the month, month itself, day of the week. All of those things are asterisks, which means any, essentially any day of the month, any month itself, repetitively, perpetually, until you remove it from your list of cron jobs. So this can be confusing to begin with, which is why there are some great resources such as the cron tab generator that asks you or that allows you to use a friendly application to generate your formatting for you, like the cron guru itself. So you can do an editing of the cron tabs by doing cron tab E, where you can select an editor such as Nano to edit the tab itself. And this is essentially what it kind of looks like when you're using one of these helpful tools right here. So if I went over here, the cron tab generator, this is what it looks like, right? So nothing crazy, nothing fancy, but just a couple of point and click that you say that you want it to run every minute, or even minutes, odd minutes, every 5 minutes, every 30 minutes, so on and so forth. Or you can just say however many number of minutes. That's what this piece right here is for, right? So I can do every 9 minutes, every 10 minutes. Let me see if I can drag this down. I should be able to drag that down. Doesn't seem like it's allowing me to. Every hour, day of the month, right? Days of the week, every month, so on and so forth, right? So it actually allows you to do a customization. And at the very bottom right here, it'll give you the command to actually run. Or excuse me, this is where you input the command to run, and then you create the cron tab line, and then it'll give you a formatted version that, oops, let me make sure I close this one. It'll give you the formatted version that will look like this, that you can actually add into the document, the configuration document for cron tabs, right? So we're deployed to the instant right here. When will the cron tab at the deployed instant 10.10.1.90.79 run? So when will the cron tab on the deployed instance run? The answer is reboot, but let's go find it. So we're looking for the specific file on cron tabs here. So this thing shrunk completely. That's pretty amazing stuff. So on this particular machine, we're looking for the cron tab. That would be at our, I think it was at the temp folder. Yeah, TMP cron tab. So let's go to the temp folder. Okay, so I don't think it's actually the TMP folder. That's my bad. I believe what we need to do is run the cron tab E potentially. So let's see if that actually works for us. Yep, there it is. So there is the actual cron jobs or cron tab configuration file. So we're going to go to the very, very bottom. There's only one specific process that's been automated for us, which is reboot. So at reboot, or excuse me, it's been at reboot where it runs this specific process, which is the processes.sh shell file. And you can assign a reboot to be your timing parameter, so that every time you just restart the computer, it'll run it, and that would be the very first process that runs. So very simple, very easy. Hopefully it's easy for you to understand as well. So let's move on to maintaining the system with package managers. When developers develop software and they want to submit it to the community, they'll submit it to the apt repository, or apt is what I refer to it as. If it's been approved, their programs and tools will be released into the wild, right? Meaning it's accessible by everybody. Two of the features of Linux that are amazing here is the user accessibility and the merit of open source tools, right? So if it's actually been approved, then it gets added to the full repo for people to just download and install at their leisure. So when using the ls command on Ubuntu, these files serve as our gateway registry right here. So if you go into the etc apt folder, you can see that these are the configuration files that are listed here for the packages that can run and can be installed. So if you look at the sources.list, for example, this is where the various locations that we can pull our repositories from can actually work. So there's the Bionic Security and the Bionic Security Universe and Bionic Security Multiverse, and then there's an individual URL that has that goes to those specific places, right? So while OS vendors will maintain their own repositories, you can also add community repositories to the list, and this allows you to extend the capabilities of your operating system. Additional repositories can be added by using the add apt repository command or by listing another provider, So for example, some vendors will have a repository that's closer to their geographical location that you can use. Managing the repositories, so adding and removing repositories, is done through the apt command. The apt command is part of the package management software, also named apt, and it contains a whole suite of tools that allows us to manage the packages and sources of our software and to install, remove software at the same time. One method of adding repositories is the add apt repository command that we illustrated, but we're going to walk through something else that is I think it's more commonly used. You can install software through the package installer like dpkg dpackage. The benefits of apt means that whenever we update our system, the repository that contains the pieces of software that we also add gets checked for updates. So in this example, we're going to add the text editor Sublime Text, which is really useful for writing code. And the repository, as it's not part of the default Ubuntu repository, so you have to add it and install it. When adding software, the integrity of what we download is guaranteed by the use of what's called the GPG, the GNU Privacy Guard keys, which is essentially the hash keys that are associated with each download to just make sure that it's legit and it hasn't been tampered with. There's safety check from the developer saying, here's the software. If the keys don't match up, then our system trusts on what the developer used, then the software will not be downloaded. So to start, we need to add the GPG key for the developers of Sublime Text. Note that the instances don't have internet access, so we can't actually do this. So this is just a sample of what you should be doing. So you're going to download the GPG key and use the apt key to trust it. So wget, as you already have gone through, wget, and then this is the, I believe, quarantine 0, so you're not quarantining it. And then this is the link itself, and then sudo apt key add, right? So you're going to get it, and then you're going to add it to your apt key. Now that we have this added to our trusted list, we can now add Sublime Text.3's repository to our apt sources list. And a good practice is to have a separate file for every different community third-party repository that we add. So in this particular case, it would be the Etsy apt sources list, and you enter that. So you create a file named Sublime Text list in this particular source list, and then enter the repository. So touch Sublime Text.list, then you ls, you see that it's here, and then you can go and add that to the repository. And the way that that would look is that you can use Nano or any kind of text editor to add and save the repository into the new file. And it's this full line that you need to add in here, which means deb for Debian, https download sublimetext.com, apt stable, make sure that it's all good. After we've added this entry, we need to update apt to recognize the new entry, because it won't just by saving it. So you need to update it to make sure that it registers and indexes in your system. This is done using the apt update command. Once it's been updated, we can now proceed to install the software that we've trusted and added to the apt using apt install Sublime Text. Removing packages is as easily as reversing the process. So you go to add apt repository, the option is remove, and then you remove whatever the name is. So for example, by manually deleting the file that we previously added to, once removed, we can use apt remove the software name, in this case, Sublime Text. This seems like a long series of commands, but you have to keep in mind that this is for a command line only operating system, or a command line version of this operating system, right? There are other ways that you can download things that are a little bit simpler. This is something that a security professional would do to make sure that the system runs smoothly every time that it's been installed and reinstalled, or installed and ran, and then when you reboot it and run it again, you just want to make sure that you have no problem, so that once it's set up, any user who's not a Linux administrator can just use the software like Sublime Text without having to worry about any of that information. So this is just a read-only portion, and it does seem like a lot, but It's something that will make more and more sense to you as you go through installing packages and getting much more familiar with becoming a Linux sysadmin. So finally here we have the system logs. So let's talk about log files. As we covered in the part 1 of our Linux Fundamentals series, the logs are located inside the var.log directory, and they contain login information for applications, authentication, services, a bunch of things. So the OS has become pretty good at automatically managing these logs, and it's called rotation or rotating. And these are some of the logs from the 3 services that are running on an Ubuntu machine. So an Apache 2 web server, the logs for the failed to ban service, which is used to monitor attempted brute forces, and the UFW service, which is used as a firewall. So the UFW is U firewall, and then failed to ban is used to monitor attempted brute forces as an example. So it monitors a few other things as well. And these are what they look like, right? So once you go inside of the actual log directory, you can see that there's a bunch of logs here. Apache 2 is one specific to the Apache 2 server. You have failed to ban, which is a series of logs that they just keep getting bigger and bigger, it seems like, or as the file type reaches a certain size that's been previously dedicated or previously declared, then that specific file type will create another file type or with just another increment to it. So 1, 2, 3, 4, etc. And it'll just keep creating those until you go through your system and start deleting them. And then the UFW belongs to the firewall, right? These services and logs are a great way in monitoring the health of your system and protecting it. Not only that, the log services such as web server containing information about every single request, allowing the developers or administrators to diagnose the performance issues or investigate an intruder's activity. For example, two types of log files that are of interest are the access logs and the error logs. So if somebody tries to access something or they have an error logging in, for example, and they get an error message saying such and such password is incorrect, and if you see too many of those, that's a red flag to think about. If an access log has gone through certain access from a geolocation or IP address that shouldn't have access to it, or attempts for access have been made, so on and so forth, all of that is very, very useful information for a system administrator or an incident responder that's trying to backtrack what just happened. There are, of course, logs that store information about how the OS is running itself and actions that are performed by the users, like authentication attempts. And again, logs by themselves are massive topic. And so you can go and learn a lot about them. This is just an overview of where they're located and just a few of these log types. So we're going to look for the Apache logs on the deployed Linux machine. And what is the IP address of the user who visited the site? So let's see. Let's go into our logs here. So we can exit out of this piece right here. And then we need to go to the var log directory, and we're here. And so we need the user, the Apache logs on the logs in the deployed machine. So the Apache logs right here. So let me see if this is a file. No, it is a directory. So we have a list of access logs that are here. So we can do, let's see, I'm going to grep for the user who visited the site. Which site though? That's the thing. So it doesn't tell me which site they want me to find. So I think I can kind of just look at the entire file itself. So let's see if we cat the access log. Let's see how massive it is. Oh, permission has been denied. Interesting. I can't even access that. That's interesting. So, okay, so let's see if we can cat the access log.1. Okay, we have one item from access log.1, and it shows that this is the IP address of the person that tried to access it. So very good. This is the IP address right here. And it says what file did they access. So you can look at everything else. So you have the IP address of the person. You have the timestamp that they tried to do, and then everything inside of the quotes in this first portion, or right here, actually, it ends right here. Everything inside of the quotes is the request that they made. So it was a GET request of the cats and dogs JPEG file, and the message was successful. So the request was successful. 200 is a HTTP response code for a successful request. And then this was the user agent that they use, which is Mozilla Windows NT, Apple WebKit, so on and so forth. Safari was the browser, all of that, right? So the request seems to be a GET request for a specific JPEG file. And that's all we needed to get, which is right here as well. So it was inside of our Apache log.1, which is accessible to us and everybody else, it seems. The access log, the very basic one right here, was not accessible by me because I am not in a sudoers file, and there was an incident that was reported to my system administrator. So there we go. And that is it. That's all we got. That's all she wrote for this particular task and this course. So we just wrapped up the Linux Fundamentals Part 3. So this was very much an overview of Linux. You can imagine that this is nowhere near what you can do with the Linux operating system. It is a massive, massive operating system. There are so many different distributions to Linux, and there are so many different purposes that a Linux operating system can serve that just you can specialize in literally one version of the distributions that are available, and you'd probably spend over a year just trying to master it. So this is not something that you can get overnight, and this was very much a fundamentals series of videos that we did for this one, and it was just a part of the cybersecurity 101 pathway of TryHackMe. So it's important for you to understand that this will not happen overnight, even though I'm going to release the Linux Plus CompTIA Linux Plus certification series, and that entire video is going to be very massive, and we're going to cover everything from the basics to advanced scripting. So all of those things are going to be covered, but it'll probably still take a lot of time for you to really wrap your head around it and become masterful at this particular operating system, which is okay, because you don't need to be a master to get a job in the business or to get good at the things that you need to do. As a recap, we went to the terminal text editor, general utilities like downloading and serving contents with a Python web server, look into processes and maintaining and automating your system with the use of cron tabs, package management, and even reviewing logs. There is the bash scripting room, and there's a regular expressions room. I want to say that I've already done the regular expressions room. I definitely have. So there is multiple sources available for you. You can just go check out the regular expressions video that's on this channel, and you can just search for regex or regular expressions on the channel homepage. And the bash scripting room, I don't think I've done. Let me see. I have actually done this. So bash scripting, we've already gone through as well. I don't know if this was a part of the fundamentals. I think it is actually a part of the fundamentals. So we're going to be going through those rooms in a little bit anyways, but you can just go try to find them. If you don't find them, make sure you subscribe and turn on the notification bell so that you get notified when those videos do come out. But for now, we are officially wrapped with this particular Linux Fundamentals Part 3 room. If you found this video useful, if you would like to get more videos on the CySec 101 Cybersecurity 101 series, I do recommend that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this particular pathway. We already have multiple videos that are out. By the time that you see this videos, there will be even more videos that are out for Cybersecurity 101. So this is an important pathway. A lot of people have requested it because it does provide the groundworks for everything else that's on this channel. Because this channel, when I came into creating this channel, I was already into like the intermediate level stuff, and I was going into the advanced stuff. So I think it's very important to have the Cybersecurity 101 playlist as well as the Cybersecurity 101 training series. So this is exactly what that is. And if you want to continue down this path, I do recommend that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out in this path. And of course, as we go into the advanced stuff, you'll also get pieces of those as well. And you'll be able to get to see all of those videos that come out. I don't mean to say that you're going to get a piece of the video, you're going to get full videos, but you'll be able to see the pieces of the advanced rooms and the tactics and so on and so forth. I feel like I'm probably not pronouncing that or explaining that very well, but I do give full videos. I don't do partial videos. I will do full videos of each tactic and each room, and then it'll be a piece of the full pathway. I should probably say that. So anyways, like, subscribe, turn on the notification bell, drop a comment, say hi, say thanks if you want to. I appreciate gratitude. Gratitude means a lot to me. But definitely just drop a comment. If you have any questions, let me know. I'll respond to all the questions that come in the comments. And if it's a big question, I will respond with a video so that you get a really good answer for it. And of course, there is the Hackaholics Anonymous membership community, which is the premier YouTube community for cybersecurity and pen testing. And it's literally, there's a lot of perks that are attached to this. This is my baby. It was something that I am very passionate about, and I want to make sure that you have access to a lot of extra tools that are not necessarily available through the other channels on YouTube or the various platforms like TryHackMe and things like that. There are certain things that as I was coming up, I realized that don't exist. For example, exclusive manuals or cheat sheets or Python automation scripts that can do a lot of things for you as you go into get a job as a system administrator or get a job as a security analyst. All of these things are available, and I give them away as a membership of the Hackaholics Anonymous community. So the first tier is our cyber support. It starts at $4.99. You get access to the Discord. There's like perks that you get access to, and then there's the special perk of a Discord server that's been designed just for that group, that you get access to me directly. You can message me or message all the advanced members that are in that group, and you have somebody to be along with you as you go down this journey of cybersecurity, as well as all the other good perks that come with having your own Discord server that communicate with somebody like us. And then there's the advanced memberships that you get the Python automations, exclusive content, manuals, etc., etc., etc. There's a lot of stuff. So if you go through the video right here, it explains all the perks for you. If you don't want to watch the video, you can just click the read more button at the bottom, and in the description you'll see all of the breakdowns of all the perks that are available as well. So that being said, make sure you check out the Hackaholics Anonymous community, which is the premier YouTube community for cybersecurity professionals and hackers. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next video. Later.